Alright, so this is my video number 26, continuation of the video number 25. My video suddenly stopped, I don't know why, so let's continue. So now we want to evaluate that CF.dr, right, where our boundary C of curve C is consists of multiple smooth curve. So in this case we have to split them one by one. So I mentioned earlier that if not mentioned, then we consider it as a counterclockwise. The direction of integration is counterclockwise. But in this case, I want to evaluate clockwise. So clockwise, we consider that side, that direction, that's consider C1, that consider C2, that consider C3, and this consider C4. Alright, this is 1, this is 1. Now for C1, look carefully. For C1, since this is multiple of smooth curve, so our closed integrals can be written as C1 plus C2 plus C3 plus C4, because we have 4 curves there. Alright, F dot dr. Okay, so consider them one by one. For C1, look at the C1. This is C1. C1 x is 0. Okay, x is 0, and y is a moving point from 0 to 1. Y is a moving point. We consider that y as a variable. Y varies. So we take x 0 because that's a line. X is 0. So x is 0, and y varies from 0 to 1. So therefore, we can let y equal to t. Alright, so where t, since y equal to t and y from 0 to 1, so t also from 0 to 1. Why t? Why not what? Just y? Just use y. Yes, you can use y. Okay, you can use just y without that part is will not affect our computation. But I try to make it try to be consistent, substituting x or y equal to some parameter, and then we can work out the rest of it, so that when we change the function or whatever it is, you will not get confused with that. So okay, so this is that we want to evaluate f dot dr. Okay, so our dr, what is our dr? Our dr is dx dt. So dx dy. So means we need to find what is dx dy. So to find dx dy, this is given from here. So we have dx, since x is 0, so dx is 0. See, x is 0, so dx is 0. Y equal to t, so dy equal to dt. Okay, so your f is given as what? Your f is 2xy plus x, xy minus y. You need to substitute all these x and y with the one that we assumed earlier, y equal to t and x equal to 0. Alright, so the integral, so therefore the integral over C1 f dot dr, that give you over, now we integrate over t because we have changed that dr everything to t. So this is t from 0 to 1. Okay, our f is 2, x is 0, times y is t, plus x is 0. Okay, so x is 0 times t minus t. That's for f, and then for x is 0 and dt. Okay, don't get confused with this. What I did here is that this is the function f, vector function f. We just substitute x and y with the curve. This is the curve. This is the curve that we describe by C1. Okay, all these things. And then you can just evaluate this. You got t equal from 0 to 1, that's 0. So you got minus t dt, that gives you minus half. Okay, then we need to consider done for C1. Now for C2, look at C2. C2 y from y is equal to 1 is a constant. Y is a constant, but x varies from 0 to 1. Alright, so we can take, in this case, we don't take y equal to t, but we take x equal to t, because t is a moving point. So we take y equal to 1 and x equal to t, where our t from 0 to 1. We need dx dy. Our dy is 0. Our dx is dt. Now integrate c2 f dot dr, that give you, okay, look at our f. So we have 2x, 2, our x is t, y is 1 plus our x is t, and then the other one x minus y, t 1 minus 1 dot, okay, dot dx dt, our dy is 0. So we have that one is 0. So this is integrate c1 t from 0, x from 0 to 1. Okay, so integrate from 0 to 1. So we have dt plus, what is this, t. Alright, so dt, so we have 2t plus t dt, that gives you 0 to 1, 3t dt, that gives you 3 over 2. Okay, and then you need to consider C3, you need to consider C4, C3. Okay, so for C3, look at the C3, x is 1, y from 1 to 0, not 0 to 1, but 0 to 1. Follow the direction that we set earlier. Okay, so we have x equal to 1, y equal to t, t from 1 to 0. Alright, so we have here dx is 0, dy dt. So you integrate f over c3 f dot dr, that, okay, c3 t from 1 to 0, our f, substitute everything, x is 0, look at that, x is 0, so you got 0 there, that one is 0, you got minus t, so you will have 0 minus t dot dr dx dy. So dx is 0, dt is dy is dt, that. So we have, what do we have? Negative t integrate 0 to 1 dt. Alright, so what is this? You have minus t squared over 2 minus, so you have half. Is that correct? Half, yeah. Sorry, this is 1 to 0. Negative, you got 0, minus half, minus positive, so you got positive half. Then we do for C4. What is C4? That C4, x is a moving, y is 0. Okay, so x is moving, so we take x equal to t from 1 to 0, y equal to 0. Alright, our dx equal to dt, our dy is 0, so integrate c4 f dot dr, that give you t from 1 to 0, and then our f our f, y is 0. Our f, look at here, y is 0, so that one is 0. Oh. Okay, this one is 0, x is t, so first component we got t, second component we got y is 0, you got 0, so t 0. So we have t 0. So we have here t 0, t 0, and dx dt, so we have dt, dy is 0, that. So the integration is integrate from 1 to 0 t dt, that give you negative half, correct? Yeah, negative half. So therefore, integration over c f dot dr, you just add up all those things, c1, c2, c3, so you got minus half, 3 over 2, half, you got minus half, plus 3 over 2, plus half, minus half. Okay, so what we have, let's cancel out, that one is 2 over 2, so you got 1. Okay, so as an exercise for you, try change the direction, see what happens. Change the direction and evaluate. So the same c here, the same c, we have that. Instead of clockwise, now counterclockwise. Counterclockwise. You may begin anyone, not necessarily here. You can start here, c1, c2, c3, c4. Up, that one should be that. Okay. Now you can start here, c1, c2, c3, c4. Anyway, you can begin with. Okay. So let me give you another example. Now, different way of writing. You want to evaluate this. This is xy dx plus y plus x dy. Okay, different than the form that we discussed earlier, but this is nothing, just f dot dr. I have explained to you this thing. Okay, f with component pq, r with component dx dy, dot product, that gives you p dx plus q dy. So that we have here p dx plus q dy. So it's just the same as close integral f dot dr. Now c is given as y x squared, y negative x plus 2, and x equal to 0. Now, we cannot see the boundary if you just look at that way. So I suggest plot a little bit or sketch a little bit. Okay, so for y x squared, so you have something like that. This is a straight line with negative slope. So we have y intersect 2, x intersects also 2, so we have that. So this is y equal to x squared, this is y equal to minus x plus 1 plus 2, and x equal to 0 is this. So this is our region. C, the whole thing, that's a C. Okay, so we might take this counterclockwise. This is C1, this is C2, this is C3. Okay, now in order to find the limit of integration, of course we need what is here. You can find the intersection of those. It should not be difficult. So this intersection, that I think you can get 1, 1. This point here is 0, 2. This point here is 0, 0. So I think that's enough. Okay. Now consider one by one. So for C1, where is C1 here? Consider that as a C1 is a straight line. What is our V? Vector that parallel to that. 0 minus 1, you got minus 1. 2 minus 1, you got 1. So that vector. And then you pick up any point. So let's say we pick up that point. So we can have those equation. X equal to x naught is 1 minus t. Y equal to y naught is 1 plus t. So this is x equal to x naught plus t v1, y equal to y naught plus t v2, and so on and so forth. You can have those. Okay. So what about the limit? If you have this, you may consider takes either x or y. So let's consider x. X from this is 1 here. X from 1 to 0. You can see here this is 1, x 1 and approaching 0. So x from 1 to 0. What happened to t? What happened to t? Look at here. If x equal to 1, t is 0. When x equal to 0, t is 1. So the integration is from 0 to 1. Okay. Now you can evaluate this thing. For C1, our x there, 1 minus t, 1 minus t. Our y, 1 plus t. Dx, you need to find dx here. Our dx is equal to negative dt. Our dy is equal to dt. So our dx is negative dt. You can have negative dt here. Then we have plus y. Our y is 1 plus t. And x is 1 minus t. dy is dt. Okay. So now we can, all the integrand is in t. We integrate with respect to t. The limit also we have found from 0 to 1 for t. So now this integrate from 0 to 1. Simplify this. What you have, multiply by negative. You got negative 1 plus minus. You got no term for t. And then you have minus t squared minus or plus t squared. That's for dt. And for this you have 1 plus t, 1 minus t. So this t cancel out, plus 2. So we have plus 2 dt. Simplify further, we have t squared plus 1 dt. Okay, you should have no problem for this. Okay, so then you can just evaluate whatever value there. Let's try that. At t cubed over 3 plus t from 0 to 1, so you got 4 over 3. Correct? So you have 1 over 3 plus 1, 3, so 4 over 3. Okay, that's correct. Okay, for C2, where is C2? Look at this, C2 here. C2, x is 0, y is a moving point. So x is 0, y is a moving point. We consider y equal to t. And the t from y from 2 to 0. So which means t from 2 to 0. We need dx, that's 0. We need dy, that's dt. Then integrate c2f dot dr that we have. Integrate t from 2 to 0. Our f, what is our, no. Here, this thing, okay. So xy d theta y. So x, our x is 0. So this term gone. All right. Here y equal to t, dy equal to dt. X is 0. So we have t dt. So if you evaluate this, you got what, t over 2 over 2. So you got minus 2. All right. Then you can consider C3. For C3, that curve, y equal to x squared. Okay, so for C3, we have y equal to x squared. C3, y equal to x squared. So if you take x equal to t, then we have y equal to t squared. Yeah, if you take x equal to t, then y equal to t squared. Where our t from, look at this, x from 0 to t. Look at your diagram, x from 0 to 1, x equal to t. So t from 0 to 1. So you have t from 0 to 1. Okay, so the rest we need to find what is dx. Dx equal to dt. Dy is 2t dt. Then you substitute everything. T from 0 to 1. Then substitute our x and y with that. So xy dx. So xy dx, x is t, y is t squared. So we have t squared. Dx is dt plus y plus x. Our y is t squared plus x is equal to t. Dy is 2t dt. Simplify everything. So you got 0 to 1. This is t cubed. Here you have plus 2t cubed plus 2t squared dt. So that we have 2t squared plus 3t cubed dt. So what you have here, 2 over 3t cubed plus 3 over 4t4 from 0 to 1, right? 0 to 1, from 0 to 1. So you can evaluate those things. Whatever it is, not difficult, let's do it. We have 1, so 2 over 3 plus 3 over 4. So what you have here, that 12, 3, 6, 9, is it 17? 4 times 3, oh, sorry, 7, 4, 8, 17. Yeah. Okay. So therefore, see all those things that you want f dot dr. You just add up everything that we have obtained, C1, C2, C3. So for C1 you have 4 over 3. C2 you have minus 2. C3 you have 17 over 12. So that gives you whatever value is. Okay. Alright, so for exercise, maybe you can try this. Evaluate C. Yeah, evaluate C. Xy dx plus y plus x dy, where C is given as y x squared and y negative x plus 2. Same with before, with the previous example, but we don't have x equal to 0. So which means in this case, if you plot the boundary for that, so we have something like that, and we have something like that. Okay, this is 2 here. So this is our R. This is our R. Okay, so I leave this part as an exercise to you, and that's the end for this video. Thank you.